Hi, welcome back to Mr. Chemistry. This is electron configuration for thallium, TL lesson. Okay, thallium happens to be element number 81 on the periodic table. So let's put an 81 there. And its atomic mass, of course, is 204. All right, since the atomic number is 81, it has 81 protons and electrically neutral, 81 electrons. And of course, we get 204 minus 81, and that gives me 123 neutrons. Pretty simple. S has two electrons, P has 6, D has 10, and F has 14 electrons. Off-ball principle says fill the lower shells first before we fill the upper shells, and we use the diagonal rules and we slide down this slide until we run out of electrons, which happens to be 81 electrons. So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p1. Okay, so what about these other guys here? We really don't need them. And so I'm just going to leave them there because we don't need them, but we ran out of them. But if you really wanted to, I guess we could go ahead and get in there and get rid of those guys. Let's see. Oh yes, let's just go ahead and back up here. And there we go. We don't need those guys, so we're just going to get rid of them. Pretty snarly. All right, now Hund's rule, which is orbital notation, tells us that we have to put an up arrow in every suborbit before we start that down arrow. Okay, so 1s, up and down. 2s, up and down. 2px, 2py, 2pz, see? Down, down, and down. Pretty simple, huh? Yeah, this is Hund's rule at its best. Okay. Notice how I put one in each up arrow before I start the down arrow. Pretty darn sorry, I have to say. So far, so good. Yep, it just takes a long time. As these elements get higher and higher up, you get more and more work involved, and it really does take a lot more time and effort to get things done. See how easy that is? Straightforward. And then we just go one with there. Okay. So our nearest noble gas, of course, is xenon. Can't use radon because that's after thallium. So we're going to, and now xenon, of course, and like all our other videos that we've been watching lately, ends in 5p6. And that's, of course, going to be Xe. And then you're going to have 4f14. 5d10. I put them in numerical order. 6s2. 6p1. Pretty snarly. Now, quantum numbers. Okay, thallium happens to be located in the p block, which is a good thing because it looks like it's in period 6, and it is in period 6. If Within the p block, its value is 1. It's also the first in that row for the p block, so it's going to be negative 1. And our last arrow is going up, so that's going to be 1/2 positive. And that's Pauli's exclusionary principle, says that no two elements can have the same set of quantum numbers. You guys be snarly, and we'll see you back here at Musin Chemistry.